Hello everyone. Today we're going to do a little introduction to arithmetic sequences. Going to show you what some symbols are. Give a couple examples. And then that'll be it. Here we go. First of all, a sequence is just a list. Math term for list of numbers. So here we go. 1, 5, 9, 13, etc., etc. Now, in order to work with these things, we have to have some symbols in order to get some equations or use some equations and do some calculating. So one of the symbols is the A, and sometimes T1. And what this is the value at the start. That is the value at the first position. Value at the first position. Next, we have Tn. This is the value at, well, whatever n is. Not n, we'll say position n. That's a nice way to say that. Right? So position 1, the value is 1. Position 2, the value is 5. Position 3, the value is 9. And so how we can write that is like this. At position 1, the value is 1. At position 2, the value is 5. And at position 3, the value is 9. And so on in this example. The n. This is the position. Or in other words, the location in the list. So are you in the first spot? Are you in the second spot? The third? Where are you? That's what n does for you. Now we're looking at a special type of list, a sequence, called an arithmetic sequence. All right, and so the arithmetic part makes it special in some way. I'm going to put the list we just had up, the sequence we just had. We had a 1, a 5, a 9, a 13, going like this. And so what makes this an arithmetic sequence is that you add the same thing each time. It's the same addition, same add, to get from one number to the next. Same add each time. See, so we start with the number 1, and then what do we add to get to the number 5? Well, we go plus 4. And then we're at our next term in the list, in the second location, second position. And then we add 4 again. And where are we at? 9. Add 4 again. 13. And so on. That's how this sequence, that's how this list is created. Alright, so actually I have to add this now to our list of symbols. So just to rehash them, so they're all in one nice place. We have A, or sometimes T1. That is the value at the start. In other words, the first position. Position 1. All right, we have Tn, which is the value at position n. So for example here, we have the value at the second position. The value at position 2 is 5. Next we had n. That was the position itself, the location in the list. First, second, third, etc. like that. Right? What's T3 equal to? Well, 9. Right? What's the position? 3. N is equal to 3. But now for this arithmetic part, we got to add this, D. This is called the common, this is the math name. Common difference. And I'll show you why in a second. But this, what this is referring to is the same add. The number that's added each time to get from one term to the other. And in this example, as we saw, it was our plus 4 that we used each time to create this sequence. Now, D. How does it get its name? Common difference. Well, here's some English for you. Common can mean the same, and then the difference, this is the answer from subtraction. Subtraction, that is. Minusing. Which I don't know if is a word, but. Alright, so we had our list here. Our sequence. 1, 5, 9, 13. And these 3 dots that mean means the pattern just goes on in the same way. Well, same answer from subtraction. Subtracting what? We'll take a look at this. If you take one term and subtract the term before it, right? You take one term and minus the term, that's an R, that's an M, it's not. Term before, right? I'm suggesting you're going to get D. So let's take a look. I'm going to choose the value of 5. I minus the term before it, which is a 1. I get 4. I'm going to choose the term 9. I'm going to subtract the term before it, which is 5, and I get 4. Oh, so the same part is starting to come out, that's for sure. Right? 13 minus the term before it, minus 9. What do we get? Ah, same again. The same what? Same answer from subtraction. So that's where the name comes from. Okay, so we built the idea of an arithmetic sequence with the same number adding each time, and D is the answer you get from doing some subtraction each time. Both can work. All right. Now, a common question is to predict or to try and figure out a particular number in the list. And not like the 8th one, because you can just do it by hand. More like the 200th one, right? Otherwise you'd be there all day adding a bunch of 4s. Unless, of course, you see the secret and you can work it out. So here's how we do it. One typical example is finding the value of some term. And I'm going to say, just for fun, T200. So not the first term, which we had as a 1, not the next term, which we had as a 5 or a 9 or a 13, right? The end values for these would be n is 1, n is 2, n is 3, n is 4. No, the question is, what's going on at 200? Okay, so you can get started with your plus 4s if you like. You can start thinking about these plus 4s if you like. All right? Or I'm just going to, well, for now I'm just going to show you the equation. And you can do it your way, I'll do it mine. And we'll see that they match. Then we'll take a look at why. So I'm going to suggest that all those letters we just learned about can fit together like this. Not only that, I'm going to suggest strongly it's like this. So A is the first term. So what you want to do is make a little list. See what we have, because we need a value for A, N, D, and Tn in order for this equation, this formula to work. All right, so A is equal to 1, that's the first term. N is the position that we're looking for. So I'd like to remind you that this symbol is written like, comes from T and then an N down below. So N is going to be 200 because it's in the N spot, which means, as I said earlier, the 200th location. What else do we got? Well, the question is find T200. So what we can do, we don't have a number for it, but we do have a question about it. So we put that in there. Because that's probably going to be the one number that's missing. Hopefully only one. Okay. Then what else we got? We got A, we got N. Oh, now we got D. Well, in this example, you can eyeball it. Or in fact, we built it from using a value of plus 4. But what you should do is actually show it. So choose a number. Subtract the 1 before it. Just a little calculation there to show what D is equal to. Right? And now we have, well, that's our information that we got for this particular question. So let's do this. Let's put the numbers in there and see what we can calculate. So T200, putting the A in there. Oh, I chose 200, eh? Okay, well, that's how it goes. And then a 4 like that. Now, I know your teacher probably told you that you simplify the brackets first in order to calculate this out by hand, right? And that's true. You mean you really should do that. But teacher also probably told you that when you got a number on the outside, you can multiply by each thing on the inside. Okay? Usually this number's out in front so that it looked like having a couple of part of a rainbow, call it, over there, but in this case it's at the back. So 4 times minus 1 and 4 times 200. This makes the numbers a little easier than going 4 times 199, which is 400, and then plus 9, which is 316, and blah, blah. Just too difficult, at least for my brain right now. So I got a 1. I got a 4 times a 2, which is an 8. Throw in a couple of zeros. And then a minus 4 for the last term there. See, this is way easier then. Distribution. That's why you learn it. So you get to 800 now. Minus 4, which is 796, plus 1, which is 797. So what we just found is the value at position 200, not position 1, not position 2, position 200, the value there is 797. That's what the sequence grows up to. So we can go dot, dot, dot. And now we can add 797 there if we wanted. Just got that figured out. All right, so this is a pretty typical example. Find the value of a term at a particular location, given some information or given some numbers in the sequence. Okay, let's go on to the next. We'll stop here, and then we'll go on to the next video to show you some other type of examples that can come from this particular topic, and also show you a little bit about where this formula actually comes from. All right, thank you, good people. Thank you for watching. Have a great day.